Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey Houston, we don't have a problem. Today the topic is thunderstorms. Boom, boom, cool things, right? Thunderstorms. And we're going to jump into a video that I made a number of years ago, and it's going to seem a little jilted, so let me kind of set it up for you. I start by talking about the layers of the atmosphere. We've got the troposphere that we live in, and then there's the tropopause, and then there's the stratosphere. And in the barrier between the troposphere and the stratosphere is called the tropopause. And if you recall, that's where the temperature, it gets colder the higher you get. But when you hit the stratosphere, it starts to get warmer. And that's very important when we talk about thunderstorms. So let's dive in.
It's the top boundary of the troposphere. This is where the temperature flattens. So remember in our diagram here, at the tropopause, see how the temperature stays constant right down here? That's called the tropopause. Now that's important to understand because as you get a thunderstorm, remember we're talking about thunderstorms, and we get this flattening out. Remember this is a convection cell, right? And as it flattens out, we kind of get a flat spot at the top. Why does it reach a flat spot? Because actually it's risen to the level of the tropopause, and when it reaches to that level, it can't go farther because now all of a sudden the temperature starts to warm up because it's dependent upon being cold. So this right here, the top of this shape, this cool shaped cloud, is where the tropopause is. So that's why they sort of flatten out and make what we call the anvil shape. Now the stratosphere is the next layer, right? Look at the stratosphere back here. The stratosphere we're talking about, which is right there, is the outer layer of the atmosphere overlying the troposphere. The air temperature is at first constant with altitude and then increases with altitude, right? Remember we looked at the picture here. It's constant, stays the same, and then the temperature rises right here. All right, here's a diagram of a thunderstorm. Remember this is caused by the updrafts. We get drafts upward, or a warm updraft. Notice we see some, you may want to sketch these or maybe print them, is we get this draft as it rises up, and then it reaches to have something called the overshooting gap. So this is the part that actually can make it briefly into past the tropopause, and it makes this anvil top. This particular storm is moving in this direction. We're going to talk a little bit about a gust front in a little bit, and here's some new cloud formation. And then, of course, as it rises, eventually it's going to make a cold and downdraft, and you can start getting rain, hail, tornadoes, and all kinds of very exciting things. In fact, here's kind of even a more intricate diagram. Here again, we have updrafts. The updrafts are causing a lot of things, but the tornadoes kind of here, they're not going to be at the front of the storm, but kind of in the middle of the storm. And here's sort of the front. This is the gust front portion of the storm. The hail tends to kind of come right in this stage, and then you get the heavy rain here, and then the light rain. So it's actually a series. So this storm, in this case, this storm is moving the opposite direction. It's moving in this direction. She starts out with the gust front right here. I had the gust front over here. I had it backwards. And then we get the light rain. Then you get the heavy rain. Then you get the small hail. Then you get the large hail. And then you can get a tornado. This is like in the worst case, right? And then you got debris because of the tornado, and then it eventually tails off. So there's kind of a whole sort of series of steps that a thunderstorm goes through, or can go through if it's really severe. Speaking of the gust front, what the heck is that? That's the leading edge of the rain-cooled, gusty air preceding a thunderstorm. It's a similar kind of like a cold front, which we talked about in the last podcast, with a passage marked by wind shift and usually a drop in temperature and a related pressure jump. So the pressure changes. So that's that gust front we were talking about. Here's that gust front. And all of a sudden you get this huge gust front. The wind that starts at the beginning of a thunderstorm can be pretty amazing.
So here we have a gust front simulation. And what happens, of course, is you get an updraft at first, but then it's this big downdraft. As the rain comes out and it races down, it then pushes air, and you get this huge amount of wind that's cooled by the quickly descending air. So you notice it's the cooler air hitting the warmer air, and if you're at the front edge of that storm, you're going to get a huge wind, sometimes very, very strong, and yeah, that's how you get a gust front.
There's something also called a downburst. All right, now downbursts are pretty amazing things too, is that because you have all this rising air, sometimes the air will immediately drop very quickly, and it can cause a huge issue. It can collapse buildings. In fact, we'll show a clip here in a minute. So it's an area of significantly rain-cooled air that after hitting the ground spreads out in all directions, producing very strong winds. You get this down, and boom, it'll just knock things down. In fact, let's watch a cool video clip.
The Dallas Cowboys are still assessing damage after a thunderstorm ripped through through their practice facility in Irving, collapsing their indoor field structure about 3:30 this afternoon. You're watching video from WFAA as it happened inside. You can see the walls start to buckle. Incredible footage of the roof coming down in a matter of seconds.
Wow, that was pretty cool. All right, now a question that's often asked about thunderstorms is, where does the hail come from? Hail, okay. So that's the ice crystals that fall out of the sky, right? Just in case you didn't know. Well, first of all, you get this updrafts. You know, this is just caused by convection. And then you get lots of updrafts, and then this hits this top here, and now we have little crystals, because above a certain point, let's say this point, it's freezing. So it's very cold. And all of a sudden it makes a little ice crystal. Well, then it falls back down. Well, that's great. Well, it falls back down. Well, once it falls back down, eventually will come as rain. But what if it hits another updraft? So if it hits another updraft, well, the crystal can get bigger, and now you have a bigger ice crystal. And if it goes through kind of a series of cycles, it goes up and down and up and down and up and down and up and down, the hail gets larger and larger and larger, and as it gets larger and larger and larger, and then eventually it's going to fall. The weight of it's going to land at the ground, and that's when you get the large size hail. So it's this updraft, freeze, fall down. Usually it'll melt, but if it doesn't completely melt, then it hits another updraft, it rises again, and it rises again, it makes another, so yeah. So here's kind of a diagram. Inside of a thunderstorm are strong updrafts of warm air and downdrafts of cold air, right? If the water droplet is picked up by the updrafts, it can be carried well above the freezing level. You don't need to copy all this down, but understand the process. With the temperatures below 32, well, it freezes. And as the frozen droplet begins to fall, carried by cold downdrafts, it may thaw as it moves into warmer air in the bottom of a thunderstorm. And that would be rain. However, our little half-frozen droplet may also get picked up again by another updraft, carrying it back into very cold air and refreezing it. With each trip above and below the freezing level, our frozen droplet gets bigger or adds another layer of ice. Finally, he falls to the ground, but now he falls as hail. Hey, what we're really kind of talking about, in this, you start with the cumulus stage, right? That's the big fluffy stage. And then you get to the mature stage, where now it gets very exciting. That's that picture that I had with all the interesting, intricate diagram. And then, of course, it starts to dissipate. That's the point where the storm is sort of dying out. All the energy has kind of gone away. And so, remember that intricate diagram right here. And so this is a mature thunderstorm. In fact, it's called a supercell in this case. Supercells can produce the tornadoes, and we'll have a discussion about tornadoes in a later podcast. But then eventually it will dissipate. But this is the mature one. We've got all kinds of interesting things that we're not going to get into. We're not going to talk about the mammatus and the rear flank downdraft. There's all kinds of the virga. You get all kinds of interesting parts to a thunderstorm, and the meteorologists, they study this in great detail. We're just going to kind of hit the highlights. So that's it for our second podcast. We will see you in class. Bye.